Right. We'll get started. So the previous class we discussed about the Ampere circuit law. Solenoid alone I was about to send it but forgot. See, I just want to remind one thing. I need a student representative from this class who can take initiative. I tell something in class, no, I want somebody to follow up on that. For example, on Wednesday, I told you that I'll be giving solenoid, but none of you have reached out to me. None of you, not even one has reached out to me saying that we didn't get this video. I want one person to take that responsibility and tell who can take that up. Vaishnavi, can you? Right. So immediately after the class is over, you need not reach out to me. You can tell him, like he'll be there, no? I think you're filling that register, right? In that itself, mention what I tell in the class. So there are two more points that you need to add, right? I'm just telling to everyone in this class, listen to this. So what she basically does is, after the class is over, there is a register to track the subtopics that have been held on a particular day. I think for second batch, you're doing it, right? Okay. So you also listen to this. What you need to do is, you need to enter the subtopics. Along with that, if I do any important announcements in the class, enter it there. For example, I mentioned about a test on the coming Saturday. Remember, did I? Yes. So that should go there. So that after that, my job will be over. They will track and keep you posted about it. Or else the message in the group will also miss and you'll get last minute information. So as a batch, I want you to work on that. Is it clear? If she forgets, somebody take up the responsibility, or if she's not available on a particular day, somebody else has to take that responsibility. Okay. So I cannot keep reminding on that aspect. Because you would have seen I have continuous classes, I'll forget. Okay. So this is one point I wanted to mention. Apart from that, yeah, the solenoid part will be updated today. It will be uploaded in the app today. You can go through it. So today, what I'm going to do is, as I mentioned the previous class, I'm going to solve the problems of I'm going to solve some important problems for each subtopic, right? And we'll see how to understand the question and approach them. As I told you, this chapter is very tough in terms of understanding the problem because you would have seen theory itself took so much of time. Does anybody have the habit of writing date? None of you? You have a? You write? Yeah. When did we start this chapter? It was almost a month, more than a month. It's almost 12 classes, right? It went for 12 classes. It will go. Right, it is big chapter. Apart from this, all other chapters are small only. Next chapter and all, I saw the syllabus. Few topics are deleted, so it will be easy. 2 classes or 3 classes, we can finish it. Okay. So this one, I'll be solving it for the next 3 days, so that for the upcoming test on Saturday, you'll be clear with whatever is going to be asked. Can we get started? Yeah. See, we'll see some problems that are based on the concept of Biot-Savart law, right? For which the formula that is used is dB is equal to mu naught times ideal sine theta divided by r squared. So there's going to be the general formula, right? Where here B stands for the magnetic field, which is measured in Tesla. I stands for current, which is measured in ampere, and R stands for the distance, which is measured in meter. So whenever you talk about Biot-Savart law, right? If you have a current carrying conductor, you consider a small current carrying element on it, which is dl. And from the dl at a point P, what do? We take a distance r, right? So when we say that this r is the distance, where is the distance measured from? It is always measured from the current carrying element to the point where we are interested to calculate the field. Am I clear with this? So this is going to be r, and the angle between them is going to be theta. Is the point clear? Right. Now, based on this, let's see the first problem. Right. So it says there is a wire that is placed along the north-south direction, right? There is a wire that is placed along the north-south direction and carries the current of 8 ampere from south to north. Find the magnetic field due to 1 centimeter piece of this wire at a distance of 200 centimeter northeast from that piece. Okay. So whenever you have a current carrying conductor and you're asked to calculate the magnetic field, there are only two formulas that you can apply. One is Biot-Savart law, and the second is Ampere-Circuital law. Right. So depending on the question itself, you'll understand whether this is related to Ampere-Circuital law or it is related to Biot-Savart law. Right. So if you observe this question, they have given a piece, a small portion of it. So whenever a small portion distance is given to us, we need to go with the Biot-Savart law. Why I'm telling this point is because I told you what is the topic we are discussing. Suppose it comes in exam, it will be a miscellaneous one. You will not know which formula to apply. Is it clear? So I hope you're able to understand. You have a current carrying conductor. That is one hint to state that this question is from 4th chapter. Second, when they say find the magnetic field due to a small piece of wire, whenever they mention about a small piece of a wire, there itself you should understand that this should be solved using Biot-Savart law. Okay. So a wire is placed like this and it carries a current from south to north. Am I right? That's what they told. Yeah, south to north. And how much is the value of current it is carrying? It is carrying a current of 8 ampere. On this conductor, we have considered 1 centimeter of wire. Right, 1 centimeter portion of the wire. From this, there is a point which is at a distance of 200 centimeters. So R is equal to 200 centimeter. But in which direction is it? It is in the direction of northeast. Whenever they say northeast, what comes to your mind? Exactly 45 degrees, right? So it is going to be like this. If I take this point to be P, right, this is going to be 45. See, in this problem, the advantage is, listen to this carefully again. In this problem, the advantage is this is also 45, this is also 45. Right. So when we apply the formula of dB is equal to mu naught times ideal sine theta the whole divided by 4 pi r square, right? When we need to apply this formula of mu naught is equal, 1 minute. Just a minute. Yeah. See, this is 45. This is also going to be 45. Sometimes what they will do is, they'll say that the angle made by this R with the horizontal, let's say it is 30 degrees. Okay. So in a problem, listen to this. If they say the angle made by this R with the horizontal is 30 degree, right? So what does the formula say? dB is equal to mu naught ideal sine theta divided by 4 pi r square. One common mistake that happens is whatever is angle given in the problem, people blindly substitute it. So what mistake will happen is try to understand. In this case, you're fine. You substitute this 45 or this 45, it will not make a difference. Whereas in this problem, if it was given like this, if you substitute 30 here and report an answer, that is wrong. Because according to this mathematical equation or the so-called formula, this theta is the angle between the current carrying conductor and R. This angle is what you need to take. So suppose, had they given it like this, what is the correct angle you should substitute? You should substitute 60. So please be careful with the fact. Okay. So what is theta? I want to stress on this point alone. Theta is the angle between current carrying conductor and R vector. Am I clear with this? Right. Now we are ready to solve this problem. See, mu naught by 4 pi, you know the value already. It is 10 power minus 7 into what is the value of I? it is 8 ampere into what is the value of DL? It is 1 centimeter. So 10 power minus 2 meter, the whole divided by R square. What is R square? 200 centimeters square. So 200 centimeter is 2 meter. So it is going to be 4. 2 square is 4 into sine of 45 degrees. Sine 45 is going to be 1 divided by root 2. So 4 will cancel this 2 times. Root 2 will cancel this 2 root 2 times. So answer is going to be root 2 into 10 power 9 Tesla, or it is going to be 1.414 into 10 power minus 9 Tesla, right? So here, though they asked only the magnetic field, means I'm understanding that the question is speaking only about the magnitude. Suppose they extend asking you what is the direction of the magnetic field at point P, what is the answer going to be? So apply the right hand thumb rule. Thumb in the direction of current, curl the fingers towards P, it is going to be into the plane. So here it is going to be of magnitude 1.414 into 10 power minus 9 into the plane. Is the point clear? Make a note of it. So let me know once you're done. Done? Shall I proceed? You need not write the question. Just write down the solution part of it. Shall I proceed? So it is 1.414 into 10 power minus 9 Tesla. Yes. The second question is, an element delta L vector is equal to delta X times I cap is placed at the origin and carries a large current of 10 ampere. So what is the direction in which the current is being carried? The previous problem they told it is from south to north. Here there is no direction that is given. So you need to look at this I cap. So that is the direction in which the element vector is, the current carrying element is, that is the direction in which the current is flowing. Right. So when you draw the diagram, how does it look? There is a point, there is an element delta L, which is of the magnitude delta X, and in this direction, considered at which point? Considered at the origin. Right. And how much is the current carried by this conductor? It carries a current of 10 ampere. What is the magnetic field on the y-axis? So read the question carefully. They told on the y-axis. So when they say y-axis, blindly, it can be above or below. It is up to us. Right. So I'll take a point above. Fine. What is the magnetic field on the y-axis at a distance of 0.5 centimeter? So which is half meter. And what is the value of delta X? Delta X is going to be equal to 10 power minus 2 meter. Am I right? 1 centimeter. So same logic. You see current carrying element by its our term. Right. So what is the formula? dV is equal to mu naught divided by 4 pi into ideal sine theta, the whole divided by r square. Makes sense? So mu naught divided by 4 pi is going to be 10 power minus 7 into what is the value of I? 10 ampere into what is the value of DL? Which is going to be delta X, 10 power minus 2 into what is the value of sine theta. Theta is the angle between the current carrying element and r vector. So how much is the angle? It is sine 90, right? So it is going to be sine 90 degrees, the whole divided by R square. What is R? R is half meter. So half square is going to be 1 by 4. So 4 will go to the numerator. So how much is answer going to be? 4 into, listen to this carefully, 10 power minus 7 into 10 power minus 2, 10 power minus 9 into 10. It is 10 power minus 8 and sine 90 is 1. So 4 into 10 power minus 8 Tesla should be the answer. For this problem, if at all you take the point at the top, according to the way the direction of current is considered, what will be the direction of magnetic field at that point? It will be outward, because when the current is flowing in this direction, you keep the thumb like this. At the bottom, it is your fingers are touching the plane. So means at the bottom, it is going to be into the plane. If you find the magnetic field in one direction, exactly on the other side, it will be opposite. So here it will be out of the plane. Am I clear? It will be out of the plane. So make a note of it. Can I proceed? So answer, what was it? 4 into 10 power minus 8, no? Yeah. So that was about Weier's-Savart law. The next set of problems that we'll be seeing is due to a special type of a conductor, which is a straight current carrying conductor. So when we talk about a straight current carrying conductor, if you recollect, there were two types of straight current carrying conductors. One was of finite length and the other was of infinite length. Am I right? So when you talk about this finite length, right? So when you talk about the magnetic field due to a straight conductor of finite length, let us take a conductor of finite length. So if I take a point P here, right, which is at a distance A from the conductor, right? So this is one end, and this is another end. From these two ends, if you join to the point P, let's say this dotted line is making an angle phi1 here, and this second dotted line is making an angle phi2 here, then what is going to be the formula? It will be mu naught I. Seriously, from morning I didn't have even one call. Whenever I start class, I don't know why they call. வெட்டியா இருந்தேன் காலையில இருந்து. So mu naught I divided by 4 pi A, right? So 4 pi A into sine of phi1 plus sine phi2. Again, one common mistake that happens here is sometimes if these angles are given near the endpoints, I repeat it. If these angles are phi1 and phi2, instead of giving in the problem near the point where the field is expected, if they give it near the endpoints itself, then the formula will not be sine phi1 plus sine phi2, rather it will be cos phi1 plus cos phi2. So you need to be careful. The formula that you're learning is applicable only when the angles are given near the end. So what I would suggest is don't remember cos. Remember the formula sine phi1 and sine phi2. But if they give you the angles here, just try to find out what are the angles at this point and substitute in the same formula. Don't confuse yourself with remembering two formulae. Rather, remember the method of converting the angle. Don't make that mistake. Am I clear with that point? Yes. So this is one formula which is very, very important, right? So by substituting the value of phi1 and phi2 to the subcategory of the special type of conductor, right, we get two other formulae. What is it? When you talk about magnetic field due to an infinitely long straight current carrying conductor, right? When you talk about infinitely long, it is going to be infinitely long. And if the point P is taken in between them, in between the endpoints, then if you take this distance to be A, then you substitute the value of phi1 and phi2 to be 90 degrees. So sin 90 plus sin 90 will be 2, and the 2 will cancel this 4 2 times, and you will get this formula, which is mu naught I divided by 2 pi A. Apart from this, there is a third formula which is not mentioned here. That is, if I take this conductor of infinite length, but instead of taking this point in between the endpoints, if I take it exactly at one of the ends, right? If you take it exactly at one of the ends, then in this case, you will substitute phi1 as 0 and phi2 as 90. So what is sin 0? 0. Sin 90 is going to be 1. So the formula you will get for this scenario will be mu naught I divided by 4 pi A. So depending on the problem, please be careful which one you're supposed to apply. Okay. Is that clear? So first you can quickly make a note of this. So don't write the whole story, just write the keywords and the formula, that's enough. Diagram, formula, diagram, formula. Is it done? Sorry, are you guys copying? Yeah, make it fast. So as I told you, draw the diagram, corresponding formula, draw it and corresponding formula. That's it. Done? Yeah. So listen to this. The question says, a current of 10 ampere is flowing east to west, right, in a long wire. So here also, if you see, there is a word wire, but you should understand when to apply Biot-Savart law and when to apply this one. So for Biot-Savart law, the keyword is going to be a small element given in it. Whereas if they mention, if they use the word long in physics, it means it's infinitely long, right? See, long in the sense it is not going to be infinitely long. Don't visualize it like that. The length is large compared to the distance where you are measuring it. That is when you call it as a large conductor. So what is happening here? I hope you're able to understand long. So when you think of long, your mind should your mind should filter out the formula that is there in your mind, right? With respect to a straight current carrying conductor, what are the two formula you have? Mu naught I divided by 2 pi A or mu naught I divided by 4 pi A. That depends on where the point is, right? So a current of 10 ampere is flowing east to west in a long wire kept horizontally in east-west direction, right? Find the magnetic field in a horizontal plane at a distance of 10 centimeter north, 20 centimeter south from the wire. That is the first part of the question. And in the vertical plane, you need to find the magnetic field at a distance of 40 centimeter downward and 50 centimeter upward. Okay. See, this is a tricky problem. I want you all to visualize it. Observe. read the question carefully. There is one important word that is used here, that is horizontal. Because whenever we think of the directions, right, north, south, east, west, by default, how will you take it? North, south, east, west. I'm showing it with respect to you. North, south, east, and west, right? This is what we do. But what plane is this? It is a vertical plane. In this case, it is not a vertical plane. The wire is kept horizontally. In the sense, if you take this to be the wire, and if this is the table on which it is going to lie, then the wire is kept like this. So which is east and which is west? Obviously, east-west direction is not going to change. This is still east. This is still with west with respect to you. But this is not going to be north. Rather, this will be north. Are you able to visualize? So if I show this will be north and this will be south, right? Visualize it like this. When the vertical plane is tilted, imagine what will happen. North is towards me, south is towards you. So you people are acting like South Pole. Is that point clear? Did you understand the first line of the statement? Next is, there are two challenges here. You need to find the magnetic field. Okay, that is common, but in two places. Where is it? One is in the horizontal plane itself at a distance of 10 centimeter north. Means from this wire, it should be at a distance of 10 centimeter towards me. Towards me, right? So when I draw it, right, I'm not going to draw a perfect rectangle. Rather, I'll draw it like this, visualize it. So this is how you're going to see when a table is there. On this table, what has happened? There is a wire that is lying on it. To this wire, this is going to be east and this is going to be west, and this point is north and this point is south, and both these points are also on the plane itself. Which plane? Horizontal plane, right? So first question is, there is a point 10 centimeter north. Formula is same. What is the formula? B is equal to mu naught I divided by 2 pi A. And one more difference, observe, when you write the formula for Bayes-Savatla, you write it as dB. Whereas when you write the formula for these kind of conductors, you directly write it as B because it is the total magnetic field. Okay. So B is equal to mu naught I divided by 2 pi A. Remember, mu naught by 4 pi is 10 power minus 7. Then what will mu naught by 2 pi be? It will be 2 into 10 power minus 7. One common mistake is some people write it as half into 10 power minus 7 because the denominator got half. The denominator got half because you multiplied with the 2 in the numerator. So am I clear with it? Mu naught by 2 pi is going to be 2 into 10 power minus 7. It gets doubled, right? Into what is the value of current? Current is 10 ampere. The whole divided by what is the distance? It is going to be 10, but this is centimeter. So 10 into 10 power minus 2, cancel this and this. Answer will be 2 into 10 power minus 9 Tesla. But I found in terms of minus 5. Yeah. So 2 into 10 power minus 5 Tesla, right? But here what I've done is I found the magnitude. But all that we need to find is in this question, the most important point is direction, right? So how do you find the direction? Imagine this is east, west, the point is here. So what is the direction in which you're supposed to place the thumb of your right hand? In the direction of current, east to west, and curl the fingers. So the hand is hitting the plane at which side? Near the north pole. So it is going to be into the plane for horizontal, but you will actually write it as your hand is going downward. No. So you will write it as vertically downward. Are you able to understand this point? So with respect to the horizontal table, it is going, the magnetic field is going in downward direction, right? So this is going to become B vector. Let me call this as B for the first question. Okay. So what is going to be the magnetic field for the second question? 20 centimeters south. So always it is better first you find the magnitude, then break your head for direction. Okay. So what is going to be the answer? Mu naught I divided by 2 pi A. So it is 2 into 10 power minus 7 into 10, the whole divided by 20 into 10 power minus 2. So basically, since the denominator got doubled, the answer will become half. Answer should be 10 power minus 5. But it's simple. Since you know, near the North Pole, the magnetic field is vertically downward. On the South Pole, it will be vertically upward. That's it. Make sense? Is the point clear? So it will be vertically upward. Right. What about the magnetic field in the third case? So it is going to be mu naught I divided by 2 pi a. The formula is still going to be the same, but we need to visualize one thing. Where are they asking? 40 centimeter downward. It is the downward is in the vertical plane. So conductor is still in the horizontal plane, but where is the point? It is somewhere over here. Right. So at this point, what is going to be the direction of field? Tell me, see, this is South Pole, this is North Pole. Tell me in terms of south, or it will be in the southward direction. For people who are not able to visualize it, I'll give you another technique of, see here, you might get confused with the right hand thumb rule. I'll give you another technique of how to find it. Listen, dB vector is there. No, the direction of dB vector is directly proportional to ideal vector cross R vector. It is directly proportional to ideal vector cross R vector. If you recollect, this is what is the vector notation of Biot-Savart law. So what is the direction of ideal vector in this case? So when you're looking at it, east to west means it is flowing from right side to left side. So tell me in terms of I cap and J cap. It is minus I cap cross, what is the direction of R vector? From this point, it is downward. So always take this point as the origin. So downward, it is minus J cap. So it is going to be minus J cap. Minus of minus is going to be plus. So I cap cross J cap is going to be how much? So K cap means it is towards you. So towards you, according to this question, means south. Is it clear? See, suppose you are not able to apply right hand thumb rule, you can still use this technique as do it as a rough work. Or you can show it here itself. Okay, so both are accepted. So what is going to be the answer? Everything is same almost. So 2 into 10 power minus 7 into 10 the whole divided by, instead of 20, we are going to write it as 40 into 10 power minus 2. So I'm looking at the first scenario. For first scenario, the answer is 2 into 10 power minus 5. Compared to first scenario, the denominator become 1/4. So the value will become 4 times. So sorry, the value will also decrease 1/4. So 2 divided by 4 is going to be half. So it will be 0.5 into 10 power minus 5 Tesla. But what is the direction? It is southward. So since this is southward, the other point obviously should be northward. If you take a point upward, it will be in the northward direction, right? So the answer for the fourth one, same formula, mu naught I divided by 2 pi a. So what will be the answer? 2 into 10 power minus 7 into 10 the whole divided by, how much is the denominator becoming? 50. So 50 into 10 power minus 2. The denominator decreased by 1/5. So what is 2 by 5? 0.4. So answer should be 0.4 into 10 power minus 5 Tesla. This time it is going to be in the northward direction. I hope I'm clear. Right? So mark this as an important problem. Right? Most important thing is not the formula, visualization. Clear? Just make a note of. Shall I proceed? From textbook. These are slightly tougher than them. Now, I think after these problems, you yourself will be able to do it. If you're still not able to do it, you can bring those problems. Okay. Can write down this mean. The next question is going to be a long straight wire, again, long straight wire carrying a current of 30 ampere is placed in an external uniform magnetic field of 4 into 10 power minus 4 Tesla parallel to the current. So there is a straight current carrying conductor like this, which is long enough and carries a current of 30 ampere, right, is placed in an external uniform magnetic field. Try to understand the tricky part here is this conductor will produce magnetic field accepted. But apart from that, what is happening? There is also an external magnetic field which is already present, right? And how is that external magnetic field? It is in the direction parallel to the current itself. So what is the value of the external uniform magnetic field that is present? Since it is uniformly, I drew this kind of a line, right? It is going to be a set of parallel lines, right? So what is going to be the value? It will be 4 into 10 power minus 4 Tesla. Is that clear? So read the question carefully. You need to find the magnitude of the resultant magnetic field at a point 2 centimeter away from the wire. Here, the question didn't mention two things. 30 ampere, okay. In which direction? Not mentioned. Secondly, they didn't tell in which direction the 2 centimeter is. So we are free to take any direction we want because the resultant will have the same magnitude. Only thing is direction will change. Since in this question, there is no direction related, we need not take the headache of finding where that point is. Is the point clear? Right. So in this case, let me say that the point is here, which is at a distance of 2 centimeter. Then due to this current carrying conductor, what is going to be the magnetic field at point P? The formula is simple. So magnetic field at point P due to the current carrying conductor is going to be mu naught I divided by 2 pi into A. What is mu naught by 2 pi? 2 into 10 power minus 7. What is the value of current? 30 divided by what is the distance? 2 centimeters. So 2 into 10 power minus 2 meter. 2 and 2 are gone. Answer is 30 into 10 power minus 5 or 3 into 10 power minus 4. So it is going to be 3 into 10 power minus 4 Tesla. But the only thing that I want to know is what is the direction of magnetic field due to this at this point? Is it outward or inward? So it is going to be outward. So it is in this direction, right? So this finger points the direction of magnetic field produced due to the current carrying conductor. This represents the direction of magnetic field which is already existing. So if you tilt and see how are they both? They both are perpendicular to each other. So if I call this as B1 and if I call this as B2, then what is going to be the resultant magnetic field? Resultant will be square root of B1 square plus B2 square plus 2 times B1, B2 cos of the angle between both. What is the angle between both? It is going to be 90. Answer will be 0. So here root of B1 square plus B2 square. 3, 4 and 5 are going to be Pythagorean triplets. So answer will be 5 into 10 power minus 4 Tesla. That's the answer. Is the point clear? Right? So just make a note of it. Shall I proceed? Right. So let's solve the next question. In figure 4.12, right, it shows two current carrying wires 1 and 2. Two current carrying wires 1 and 2. Find the magnitudes and direction of the magnetic field at points P, Q, and R. Right. So if I take at point P, what is going to be the magnetic field? So magnetic field at point P is equal to magnetic field due to the first conductor plus the magnetic field due to the second conductor. There is a mistake in the expression that I wrote. It is a vector sum of the magnetic fields. You should not directly write it. So please be careful with the directions. Okay. So what is the direction of magnetic field due to the first conductor at point P? So always you're dealing with vector, first find the magnitude. What is the magnitude? What is B1? It's a long wire, right? So for the long wire, what is going to be the formula? Mu naught I divided by 2 pi A. So mu naught by 2 pi is going to be 2 into 10 power minus 7 into what is the value of current? It is going to be 20 divided by what is the value of A? It is 10 centimeters. So 10 into 10 power minus 2. This will cancel the 0. So 2 into 2, it is going to be 4 into 10 power minus 5 Tesla. Now this is the magnitude part. What is the direction? If I write it in terms of direction, so it is going to be, and that is why I wrote it in vector form. This is correct. This principle of superposition. Okay. So B1 vector is equal to 4 into 10 power minus 5. What is the direction? It is out of the plane, right? Now, what about B2 vector? First, find the magnitude. So what is the magnitude? Mu naught I divided by the same formula 2 pi A. Mu naught by 2 pi is going to be 2 into 10 power minus 7 into what is the value of I? I is going to be 20, the whole divided by what is going to be the A is how much? 10 plus 10 plus 10. So it is going to be 30 into 10. Oh, current is 30 ampere. Okay. So 30 divided by 30 into 10 power minus 2. So 30 and 30 are gone. So you'll be left out with 2 into 10 power minus 5. But this time it is going to be into the plane. Observe. So direction of current, curl the fingers, it is hitting the plane. Right? It is going to be into the plane. So you can look at the magnitudes. Based on that, you can take whichever has highest magnitude to be positive and then solve it. Or you fix the direction in the problem itself. So for example, In this problem, let's say if the magnetic field is outward, you want to take it as positive, then inward, you take it as negative. This is to be followed for each point. Don't change it. Is the point clear? So what is going to be the magnetic field at point P? It is going to be 4 minus 2. I'm not writing that step. I hope you're able to understand. This is positive. This 2 is negative. So it will be 2 into 10 power minus 5. But which one is dominating? Since you are getting a positive value. So since you're now you need to do the reverse analysis. Since you're getting a positive value, the resultant magnetic field is out of the plane. So if you write like this, you need to put a dot and a circle around it. Are you understanding how to handle directions? Is the point clear? Right. So I'll give you 3 minutes time, solve for Q and R and also tell me. Make it fast. Subtract both. 4 into 10 power minus. Positive value, positive. This value is positive or negative? Positive. Done. What is the answer for Q? Is it the resultant or anybody else with the answer? So for 20, it is going to be how much? So due to 20, it will be 4 into 10 power minus 5, but it will be into the plane. And due to 30, it will be 2 into 10 power 30, it will be 6 into 10 power minus 5 into the plane. 6 into 10 power minus 5 into the plane. So the overall answer is supposed to be 10 into 10 power minus 5 into the plane. How many of you got that for Q? Red minus lada. Add the other minus 10 and so on. Minus 4, minus 6 then. So minus 10. Minus 10 into 10 power minus 5 Tesla. That will be, yeah, minus sign indicates it's into the plane. Is there anyone who is confused? You want me to solve and show? That's correct. 10 power minus 4 is also right. But see, everywhere standardized it's there as 10 power minus 5 another update. Okay, let me solve it. So at point Q, how are the conductors? This is 20, this is 30, right? 20, 30. And the point Q is kept here. This is at a distance of 10 centimeter. This is also at a distance of 10 centimeter. And point R is also at a distance of 10 centimeter. Makes sense? Yes. Now see, at point Q, what are we supposed to do? Due to the first conductor, Due to the first conductor, what is the magnetic field? It will be mu naught I divided by 2 pi into A. Mu naught by 2 pi is going to be 2 into 10 power minus 7 into what is the value of I? It is going to be 20 divided by what is the value of A? It will be 10 into 10 power minus 2. Right. So this will cancel this 2 times. Answer will be 4 into 10 power minus 5 Tesla. So how is it going to be? It is going to be into the plane. Into the plane. So what about the magnetic field due to the second conductor? It will be mu naught I divided by 2 pi A. So mu naught by 2 pi is going to be 2 into 10 power minus 7 into what is the value of I? 30. The whole divided by what is the distance? Distance is still 10. So 10 into 10 power minus 2. This will cancel this 3 times. 3 into 2, that is going to be 6 into 10 power minus 5 Tesla. This time also it is into the plane. So here also it is into the plane, right? So this is also written in the vector form. So since both are into the plane, how is the resultant magnetic field at Q going to be? It will be 10 into 10 power minus 5 Tesla into the plane itself. Is the point clear? So you understood why I added these two values? Because they have the same direction, right? In a similar way, if I take the point R, for point R, what is the magnetic field due to the first conductor at R? Same formula. Formula is not going to change. Only thing, numbers will change. So B1 is equal to how much? Mu naught I divided by 2 pi A. Mu naught by 2 pi is going to be 2 into 10 power minus 7 into what is the value of I? Same 20. The whole divided by what is going to be the distance this time? It will be 30. Right? It will be 30 into 10 power minus 2. 0 and 0 are gone. It is going to be 4 divided by 3. All right. So 4 by 3 into 10 power minus 5 Tesla. In which direction is it going to be? It is going to be into the plane. Direction of current, curl the fingers. Your fingers are going and hitting the board. So it is into the plane. Why will it be 6 by 3? 20 only, no? So what is the value of B2? B2 will be mu naught I divided by 2 pi A, which is going to be 2 into 10 power minus 7 into what is the value of current? Again, 30 ampere divided by what is the distance this time? 10. So 10 into 10 power minus 2, 0 and 0 are gone. 3 into 2, it is going to be 6 into 10 power minus 5 Tesla. What is the direction? Current is in this direction. So at point Q, it is going to be into the plane. This side, it should be out of the plane. So you put a dot and a circle around it. So what is going to be the resultant here? So resultant is going to be, so we took outward as positive. No, 6 minus 4 by 3 is going to be 18 minus 4. So it is 14 by 3 into 10 power minus 5 Tesla, which is going to be out of the plane, because out of the plane is going to be of greater value. Did you understand? 6 minus 4 by 3. Why did I put minus? Because 6 is positive, 4 by 3 is negative. Am I clear with this, everyone? Right. Yeah. 1 minute. Oh, 4. Clear with this? Right? So this will be the last problem for today. There is actually one interesting problem which I'll start tomorrow. This one. This one will make use of the formula mu naught I by 4 pi into sin pi 1 plus sin pi. I'll tell you how to calculate. Okay. So after this mostly I think this is over. With straight current carrying conductor will go, then we'll go to circular current carrying. So if anybody is copying, make it fast. You're done? Okay. Any questions? All clear? Okay then. So I'll see you tomorrow. Even the try out the example problems. You didn't shut up. It isn't perfect. The ones I'm doing are perfect. I'm sure you will be able to do it now. But actually, what you do is everyday basis, whatever concept I'm teaching, right? Parallelly work out those problems from textbook. Maybe easier problem. And exam, exercise is very simple. 12 problems tomorrow. It's very, very simple. Direct formula. Sorry.